This lecture is for AP Biology on the chemistry of life. First, starting off with the introduction to matter. Matter is anything that takes up space and has mass. Organisms are all composed of matter, and matter consists of chemical elements in pure form and in combinations that we call compounds. Here we have a figure showing the creation of a compound. If you take solid sodium, add to that chlorine gas, you make sodium chloride or salt. An element is a substance that cannot be broken down into other substances by chemical reactions, and a compound is a substance that consists of two or more elements in a fixed ratio. It's important to note that compounds has characteristics that are different than that of its elements. There are four main elements of life, that is carbon, hydrogen, oxygen, and nitrogen. Together they make up about 96% of living matter. The remaining elements consist of calcium, phosphorus, potassium, and sulfur. Trace elements are those that are required in very small quantities. These are important to know, specifically the CHON, the main four, or CHON, but also the carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur as well, as far as the main elements that consist of life. Here is a breakdown of the elements found in the human body, and just to note, oxygen makes up the majority of the human body, about 65%. Next, we're moving on to a simplified model of an atom. Specifically here, we're looking at the helium atom. One important message from this lecture is that an element's properties depend on the structure of its atoms. Each element consists of unique atoms. An atom is the smallest unit of matter that still retains the properties of that element. Atoms are composed of subatomic particles. These subatomic particles are neutrons, which carry no electrical charge, protons, which carry a positive charge, and electrons, which carry a negative charge. Neutrons and protons form the atomic nucleus, and electrons form a cloud around the nucleus. Neutron mass and proton mass are almost identical, and they are measured in Daltons. Next up would be the representation of various different elements on the periodic table. Atoms of various elements differ in the number of subatomic particles that they contain. An element's atomic number is the number of protons in the nucleus. An element's mass number is the sum of the protons plus the neutrons in the nucleus. And the atomic mass is the atom's total mass, and that can be approximated from the mass number. All atoms of an element have the same number of protons, but they can differ in the number of neutrons. Isotope is a term given to two atoms of an element that differ in the number of neutrons. Radioactive isotopes decay spontaneously, giving off particles and energy. Here we have the three isotopes of hydrogen, and just to note, in protium you have one proton, so it has an atomic mass of 1. In deuterium we have a proton and a neutron, so it's got an atomic mass of 2. And tritium has a proton and 2 neutrons, which an atomic mass of 3. They all have the same number of protons but differ in the number of neutrons. Back to radioactive isotopes, there are several important applications in biological research, and those include dating fossils, tracing atoms through metabolic processes, and also diagnosing medical disorders. The chemical behavior of an atom is determined by the distribution of electrons in electron shells. Valence electrons is a term given for those in the outermost shell, also called valence shell. The chemical behavior of an atom is mostly determined by the valence electrons. Elements with a full valence electron, like the noble gases on the far right-hand side, are chemically inert, meaning they do not react. There are different types of bonds that we're going to talk about. The first is a covalent bond. Here I have two hydrogen atoms that both have one proton and one electron. Atoms with incomplete valence shells, like the hydrogen atom shown here, can share or transfer electrons with certain other atoms. These interactions usually result in atoms staying close together, held by attractions that we call chemical bonds. In this case, when the hydrogen atoms become close enough, they will actually share the one electrons, completing the valence shell. The first valence shell of an element can hold 2 electrons. So when these hydrogen atoms, that have 1 electron each now share those electrons, they now have a hydrogen molecule, each with 2 electrons that they share. A covalent bond is the sharing of a pair of electrons by two atoms. In a covalent bond, the shared electrons count as part of each atom's valence shell. A molecule consists of two or more atoms that are held together by covalent bonds. Atoms in a molecule attract electrons to varying degrees, and we call that electronegativity. Electronegativity is an atom's attraction for the electrons in a covalent bond. The more electronegative an atom is, the more strongly it pulls electrons towards itself. The most electronegative element is fluorine. You can see on this picture here that electronegativity increases as you move across the periodic table and also up the periodic table. This means that fluorine has the greatest pull of electrons towards itself. In the example picture on the bottom right side, there's a molecule of water. Oxygen has an electronegativity much greater than that of hydrogen, which means that the oxygen atom pulls the electrons from the hydrogen closer to itself than it is to hydrogen. That results in an uneven balance of charge across the water molecule. Because the electrons, which are negatively charged, hang out more around the oxygen, that part of the molecule carries a slight negative charge. And the hydrogen atoms, because the electrons are not around it, then carry a slight positive charge. There's two different types of covalent bonds that can occur. Nonpolar covalent bonds, atoms share electrons equally. This will happen if atoms have equal or very near equal electronegativity values. In a polar covalent bond, one atom is more electronegative, resulting in the atoms not sharing the electrons equally. Unequal sharing of electrons causes a partial positive or negative charge for each atom within the molecule. And again, we're looking at water, and because the electrons are more around the oxygen part of the water molecule, the oxygen carries a slightly negative charge while the hydrogens carry a slightly positive charge. Another type of bonding is called ionic bonding. This involves atoms stripping electrons from their bonding partners. An example would be, like we have here, the transfer of an electron from sodium to chlorine. After the transfer of the electron, both atoms will then carry charges. Sodium atom has 1 electron in its valence shell. The chlorine atom has 7 electrons in its valence shell. To have a full valence shell, they want 8 electrons. So when sodium donates an electron to chlorine, that results in an ionic bond because sodium, since it has lost an electron, now carries a partial positive charge and is called a cation. Chlorine, because it has gained an electron, carries a negative charge and is called an anion. That attraction between the sodium and the chlorine is much like a magnet, with the positively charged sodium being attracted to the negatively charged chlorine. An ionic bond is the bond that's formed when there's attraction between an anion and a cation. Compounds formed by ionic bonds are called ionic compounds or salts. Salts, such as sodium chloride, are often found in nature as crystals. So here we have an example of a sodium chloride crystal. Another type of bonding is a hydrogen bond. While most of the strongest bonds in organisms are covalent bonds, there are weak chemical bonds such as hydrogen bonds, and these are very important. Weak chemical bonds can reinforce the shapes of large molecules and help molecules adhere to one another. Hydrogen bonds are formed when you have a polar covalent bond involving hydrogen that results in hydrogen carrying a partially positive charge attracted to the partial negative part of another molecule that is negative because of a polar covalent bond. Again, the positively charged hydrogen in this example is attracted to the negatively charged nitrogen. Nitrogen is carrying a negative charge because it is much more electronegative than hydrogen, so the electrons hang out more around the nitrogen than they do around the hydrogens. So that molecule of ammonia, NH3, now carries a slight negative charge around the nitrogen and a slight positive charge around hydrogen. That is an electrical attraction between the negative region of the nitrogen and the positive region of the hydrogen in another molecule. The final type of bonding that we're going to talk about is van der Waals interactions. This happens when electrons are distributed asymmetrically around molecules or atoms. This happens just by chance. Electrons are constantly moving, and so because of that, there will be circumstances where sometimes the electrons are more on one part of a molecule versus another. This results in hot spots of positive or negative charge. Van der Waals interactions are attractions between molecules that are close together as a result of these charges. So if by chance you have a distribution of electrons on one side, that'll lead to a negative charge on one side of a molecule, I almost made it, and a positive charge on the other side of a molecule, and those interactions create a weak bond. These interactions can be strong, such as between molecules of a gecko toe's hair and a wall surface.
Thank you.
And finally, just to say, chemical reactions make and break bonds. Here we have an example of two reactants that are yielding two products. So the starting molecules of a chemical reaction are called reactants, and the final molecules of a chemical reaction are called products. And that is the end today.